Okay, RMI stands for Remote Method Invocation. So this is actually a pretty long presentation, and I don't think I have time to cover them all. So we are going to cover maybe up to Codebase here. So hopefully we cover at least the basic concept of RMI. So we'll start with what is RMI and why you want to use RMI and some architectural components and the concept of serialization in the context of RMI and how we can write RMI server and client, and then concept of dynamic class loading and code movement and code base. And hopefully that should give you enough information on how to write RMI code. So what is RMI, remote method invocation? It is a scheme of remote procedure call scheme between Java objects. So we have Cobra in the past, right, and DCOM in Microsoft world. They are all, in a sense, remote procedure call scheme. The difference between RMI against those schemes are RMI is for Java objects. So it basically provides a similar RPC behavior. So it lets you invoke remote methods. And when you call the remote method, you can pass arguments, and then you can receive result from the execution of those remote methods. If you think about remote procedure call scheme evolution, in the beginning there was non-object oriented RPC, and then CORBA is like a semi-object oriented, and then RMI is completely object based. But this is actually Java, between Java objects. And I'll actually explain what this means in a bit more detail later on in this presentation. So this is a little bit of repeat of what I just said in the previous slide. Differences from other RPC schemes. So RMI is Java based, meaning it's a remote procedure call invocation scheme between two Java objects. And RMI supports code movement. In fact, I think this is the biggest, benefit of using RMI is hugely this is actually very unique feature of RMI. So you can actually have a code being moved between Java objects. And I'll talk about what that means in the rest of the presentation. RMI has a built-in security mechanism because you are in fact executing code that came from remote location. Obviously, you should have vigorous security scheme and it's built in. And RMI expose network failures to application programmers through remote exception, meaning because you are executing some code running on the server, the failure could happen any place. It's called a partial failure. So RMI's philosophy is instead of hiding that kind of failure, it will expose that failure through remote exception so that client application at least can do something about it. Okay, so why you want to use RMI? So it capitalizes on Java object model. So it could be in fact pros and cons. So if your environment is completely Java, then RMI is a good thing. But if you are not using Java in one of those participants in the communication, then RMI is not available on that environment. Minimize the complexity of distributed programming. So everything in Java in RMI, so it actually simplifies the programming model and uses a pure Java interfaces. So in CORBA, they have what is called the interface definition language, IDL. So by using IDL, you are going to define the service contract between client and service provider. In the case of RMI, you are going to use Java interface for that purpose. So everything is in Java in RMI. There is no XML file involved in RMI. It preserves the safety of Java runtime. So again, it's built. The security scheme of Java is actually also actually used for RMI. And again, it recognizes the differences of remote call from local call. So it assumes there is a partial failure possibility and latency and no global knowledge on system state, meaning when the client makes a call to the server and when it fails, it doesn't know where it failed, right? So again, that's the philosophy RMI, exposing remote exception to the client so that client can do something about it. Okay, moving forward. Architectural components. So RMI architectural components are not that much different from other the RPC scheme. So remote interface is basically defining the service contract between RMI client and RMI service provider. Again, in this case, it's going to be in the form of Java interface. And then you have stub and the skeleton. Stub is on the client side and skeleton is on the server side. And they are generated through RMI RMI compiler that comes with a JDK. And then you have to create remote object. So these are basically architectural components that make RMI environment. Okay, moving forward. So let's talk about remote interface. So this is a pure Java interface, and basically it specifies methods that could be accessed by the client. So it specifies remotely accessible methods, and this interface has to be implemented by remote service implementation class, and the object instance of that remote service implementation class is a remote object. And basically it is again contract between caller of remote method, in this case RMI client, and remote object, which is functioning as RMI server. And this is basically java.rmi remote interface. So it's a markup interface. It doesn't have its own methods. Okay, stub and skeleton. So the concept of stub and skeleton is not something new in RMI. I mean, just like any other RPC scheme, RMI also has stub and skeleton. And these stub and skeletons are created by RMI C compiler. So we are going to see how we can use RMI C later on in the hands-on lab. So typically you are going to actually generate a stub, and skeleton is going to get generated through reflection. In the early version of RMI, you have to create both RMI stub and skeleton yourself. But later version of RMI, you just create the stub and the skeleton gets created automatically. Okay. By the way, you want to use RMI C compiler for the server implementation class, not RMI interface. So a bit more detailed information on RMI stub. So stub resides in client's local address space. So stub is actually playing the role of proxy of remote object. So client thinks that it's talking to remote object, but it is actually talking to RMI stub. Okay. The reason it's actually possible is because RMI stub is implementation of remote interface, right? Because remote interface is a Java interface. The client is just talking to the interface. But during runtime, the stub object will be bound to that remote interface. And so client is actually talking to this stub object rather than remote object, because remote object actually reside in the remote server. Okay, so caller invokes methods of RMI stub locally through RMI interface. And it is the responsibility of the stub object that actually make a connection to the remote object. And it actually sends the arguments. And also, it sends the arguments when it actually calls the method. And then it receives the result from remote object as well. So as part of sending arguments and receiving result, it has to perform marshalling and unmarshalling. So we'll talk about the concept of marshalling and unmarshalling in a few minutes. Basically, it's a serialization of parameters and the serialization and deserialization of the result from the remote method invocation. So skeleton is on the server side, so it is actually playing the same role of RMI stub, but it is on the server side. So it receives arguments from the caller, and then sends the result back to the caller. So just like RMI stub, it is responsible for marshalling, unmarshalling objects. And so when you receive the request, it figures out which method of remote object to be called, and then it will call it. And then once the method, remote method, actually perform the business logic and return result, and result will be again marshaled and sent back to RMI stub on the client. So as I said before, from JDK 1.3, RMI skeleton gets created automatically via reflection, so you don't have to create it yourself. Okay, so concept of remote object. So remote object is basically an instance of a class that implements that remote interface. And this one needs to be exported in order to receive calls from the client. Okay, so when we say exported, meaning it is up and running, waiting for the call from the client. Now, there are two different ways that you can export a remote object. One is non-activatable mode, and the other one is activatable mode. So non-activatable mode is you are going to extend unicast remote object class, while for activatable remote object, you are going to extend activatable class. Since we are not going to have time to talk about the activation, let me just talk about the difference between non-activatable remote object versus activatable remote object. Non-activatable remote object is up and running all the time. Okay, so once you export it, it is up and running. Okay. Now, the problem of that approach is that suppose you got maybe very large number of remote objects up and running, and if those remote objects are invoked, let's say, once per year, that means you're consuming a lot of resources on the server side, right? So instead, what you want to do is you want to have a remote object to be activated when it is invoked. Okay, so in that case, suppose again you have a 10,000 remote object, and if you're using one of those 10,000 objects once a year or something like that, that object will be kind of dormant until it gets invoked. When it gets invoked, and then it gets activated and ready to serve. Okay, so in a sense, activatable remote object is to conserve the resources on the server side. Okay, moving forward. RMI communication model. So I talked a little bit on this. So this is basically you have a caller, meaning client, RMI client, and then we have a remote object, and we have a stub, and we have a skeleton, right? And the client side is talking to stub. Client thinks it is talking to remote object, but it is in fact talking to stub, and stub will actually marshal the arguments of the method and then send the request to the skeleton, and skeleton receive it, and then it will invoke the methods and things like that. What is important here is that the stub object has to be remote interface type. Okay, so it's using Java interface type to talk to the stub. Okay. So this one gives you a step-by-step process how things work. Again, this is something I have already talked about. So client object will call a method on the stub, and the stub, so this is a stub and this is a skeleton. So stub implements that Java interface, remote Java interface, and it marshals the arguments, and then it passes the call to remote object. So that's number 3. And skeleton receive the call and argument, and then it will actually process the call. So it will actually talk to remote methods, and then result will be returned, and then it will marshal that result and send it to the stub, and stub will unmarshal the results and send it to the client. Okay, so pretty straightforward model. So this is a bit of repeat of what I said. So caller invokes a method of remote object, and then stub receive the call and intercept the method call, marshal the arguments, and then makes a call to remote object. And the remote object here basically skeleton. So when I say here in this slide, remote object, I'm talking about the skeleton plus remote object. So receives the call via skeleton and unmarshal the argument, performs the call, and then marshal the result and send the result to the client. And then on the client side, we see the result, it unmarshal the result and return result to the client. Okay, moving forward. Serialization in RMI. So we use the term marshalling and unmarshalling, and basically we are talking about serialization of those objects. So marshalling is a process of encoding objects to put them on the wire. So we are talking about a serialization. We already covered the concept of serialization as part of this course. Okay, and unmarshalling is deserialization. So it is a process of decoding from the wire and placing object in the address space. And so RMI is using Java programming languages, serialization and deserialization, in this case object serialization and deserialization, to perform marshalling and unmarshalling. So in this presentation, we are going to use the serialization and marshalling and for the same thing. So we are using those two terms interchangeably, and same thing for deserialization and unmarshalling. Okay, so serialization in RMI. So as we talked about, arguments and results get serialized before being transported by the sender, and same thing by the receiver as well. Now, there are two different kinds of objects in the context of RMI. One is a remote object, and the other one is non-remote object. So let's see the difference between these two. Remote object is an object whose class is remote interface type. Okay? And non-remote object is object which is not, whose class is not remote interface type. Okay? So for remote object, what gets serialized on the wire is the stub object, not the real object. So it is in a sense passed by reference, because real object stays where it is actually created. But what gets serialized and passed over the wire is a stub object. However, for non-remote object, it is actually a real copy of the object. So it is serialized, normal serialization of that object. Okay? So it has to be the type of serializable. So in a sense, this is a pass-by value semantics, because it's a real object gets actually transported over the wire. So in this example, we are seeing both remote and non-remote objects. So let's take a look at this example first. So here, let's say we have an interface called the say hello string remote, which extends remote, but the method. So let's focus on this method. So here we are basically dealing with a string object, right, which is not remote type, right? So here, these objects, in this case message, the argument of message, and result of string type will be non-remote object type, meaning it will be serialized. So it's passed by value semantics. Now in this case, so we have defined say hello string remote object, which is a remote type. Now we are passing that object as an argument. In this case, the string object and the string return value will be serialized as passed by value. However, this object, because it's a remote type object, what gets serialized is a stub object of this, not the real object of this. Okay, hopefully you got the sense of the difference between remote object and non-remote object. Okay, so when we talked about the what gets created into serialized copy in the presentation and hands-on level serialization in this course, so let's go over this one more time. So when we created serialized file of an object, for example, basically it's a stream of bytes, and it maintains a state of object, meaning it will contain state of the variables of that class. Okay. However, it does not contain class bytecode, as we talked about. Okay. Instead, what is included in the serialized file is information about the class. So it contains information about where to get the class bytecode. Okay. So what that means is it is called the Codebase annotation, meaning where it can get the class files. Okay. So the class file itself is not part of the serialized copy of an object, but information about the code base, meaning information about where to get the class file is in the serialized copy of the object. Okay. Now, who performed this code base annotation? So meaning when you serialize an object, right? Who's actually providing this the code base annotation information? Okay, that's actually something that we are going to talk about. Now, if the class is unknown to the recipient, it will be downloaded automatically, meaning suppose client receive the serialized object, right? And that serialized object says, I need a class. Well, this is a serialized object of class XYZ. And it contains the state information about the fields of the class, but it doesn't contain the class itself. Instead, it contains what is the name of the class and where to get the class. So if the class is not in the class path of the local class path of the receiver, then it has to get it from somewhere. That somewhere information should be inside that serialized copy of the object. So serialized copy defines state and the class file defines a behavior. Now, when you move this serialized copy of an object, both of the state and the behaviors are in fact moved around. Even though you are not moving the class files, but you still actually move around the information about the behavior of the class, right? So this is why we call code movement. So you can actually move code between Java objects, whether those Java objects are separated by 3,000 miles away. Okay, so we are going to actually move on to the steps of writing RMI server and RMI client, and I'm going to give a demonstration. Again, for those of you who have an access to hands-on lab, you can download the hands-on lab and you can try things with me together. So writing RMI server. So these are the steps that you are going to follow. Define remote interface. So this is a genuine Java interface. Okay, again, this is a contract between RMI client and RMI server. And then you are going to write and compile server implementation class. And then you are going to generate a stub class from server implementation class that you just compiled here. And then you are going to write a startup class for starting up the server, the remote server. Okay, so let's move on. So define remote interface. So as I said before, this is a genuine Java interface that defines methods that could be called remotely from RMI client. And those methods need to be declared public. And again, this remote interface has to extend java.rmi remote interface. And each method must declare remote exception. So again, as I said before, every method in remote interface methods has to declare remote exception. Now, the data type of any remote object that is passed as an argument or return value has to be declared as remote interface type, not implementation class. That makes sense because in the client, you are going to use interface of those remote object rather than the actual class, right? Okay, because you're using stub class on the client. Okay, so this is a very simple remote interface example. So here we have hello interface and extends remote, and we have a single remote method called say hello, and it throws remote exception. Very simple interface. So you are writing hello world example here. We have RMI client is invoking this method. And let's take a look at the server. So the next step is writing server implementation. So this server implementation has to implement remote interface that we just saw in previous step. And you can extend one of these two remote classes. Again, this is for non-activatable object. and this is for activatable object. Okay, so when you are extending this class, you're basically saying when I export it, that remote object will be up and running. Okay. Now we are going to write a constructor of remote object by extending one of the two remote classes that we just talked about here. And again, you have to throw remote exception. And then you have to register your remote object to what is called the RMI registry. Okay. So as we will talk about in another slide later on, RMI registry is basically a naming server where you can register your remote object with a symbolic name so that a client will find out the remote object reference, get the remote object reference through this RMI registry. So it is a naming service. So this is the implementation. So we have hello info class extends, in this case, unicast remote object, and it also implements that hello interface that we have seen. Okay, and we provide implementation of that say hello method, right? And again, it throws remote exception, and then we basically in this case just return hello and name, which is receive from the client. Okay, so question for you guys: is this a remote? So this well actually is just too simple. Is too simple a question, I guess. So this is the non-remote object, right? This string is non-remote object. Okay. Okay, and then we are going to generate. Well, of course, you have to compile this hello info class. Once you compile the class, then you can use RMIC compiler. So it is called the RMI compiler from the implementation server implementation class, and then it will generate hello info stub class. Okay. And then you're going to write a startup code which contains main method, and here you're basically create and export remote object. I'm going to actually explain this statement using an example in the following code, and then you're going to register remote object with RMI registry. Okay, so this is the code. So here we created hello info object, right? By actually creating hello info object, because it's extending unicast remote object, it is already exported it. Okay, meaning it is now up and running, waiting for the client request. Okay, so that is in fact from the constructor of unicast remote object. So once you create it, in this case hello info object, then because it's a child class of unicast remote object, the constructor of this unicast remote object gets called. Inside a constructor, it is exported, meaning it is up and running. It gets started, meaning it gets created first, and then it is actually up and running, waiting for a call from the client. Okay, and then we bind that remote server object, remote object with this name, hello. Okay, so now this hello info remote object is up and running to be able to be invoked by the client. All right, so as I said before, RMI registry is a simple naming service. It is a bootstrap mechanism, so the client at least has to have, the starting remote object, right? Okay, so it is used by the caller, meaning RMI client, to get the remote reference of the first remote object. Once you got the first remote object, then you can actually use that remote object just like any other Java object. So client gets reference to remote object. Basically, it actually gets the stub object of remote object. Okay? Because what gets serialized from RMI registry in this case is basically stub object, that remote object. Okay, moving forward, writing RMI client. So steps for writing RMI client is very simple. First, you're going to get a reference of remote object through RMI registry, and then you invoke remote methods. Very simple. So this is a code. So you're going to use RMI registry lookup method, and then you provide a name of the first remote object that you want to get a reference. So here it returns that object, and see the type of this. This is a hello interface type, right? Even though this lookup object returns a stub object of hello server implementation, because you're using hello interface, it still should work. So instead of talking to remote object directly, now it's actually talking to, in this case, it's talking to that proxy object, meaning the stub object. Okay. All right, so let's do our first exercise. It's a very simple exercise. Okay, so let's take a look at the code. So here we are going to create a project directory, and then we define remote interface, and then we are going to compile that remote implementation class. Then we create a stub object from remote implementation class, and then we are going to write and compile the server code. Actually, this is the startup code, I should say, and the client code. And then we have to start the RMI registry, and then we are going to run the server and client. Okay. All right. So here, let's try this. So I am going to create RMI registry. Yeah, I think I already have it. RMI. Okay, so I have my project and RMI app, okay, as described here. And so we are going to create remote interface. I have already created this code, so let me just to show you what I have. So I have hello interface Java. So if you take a look at this, again, it's a very simple hello, say hello method, and throw remote exception, and again, it has to extend remote interface. Okay, and then I'm going to write the server, implementation class. That's hello impl class. So here, if you type hello impl, it is extending unicast remote object, as we have seen in the slide, and it also implements hello interface, right? And we are basically providing a very simple implementation of the say hello method. Okay, so very simple. So next step is, so we just wrote the implementation class, and then we are going to compile. So I'm going to compile. So I have now, the hello input class and the hello interface class. Yeah, so these are the code that we are going to write now. Okay. All right. Now we are going to generate a stub class from the remote implementation class. So I'm going to use RMIC hello impl. So it should create hello impl stub class. Okay. Now, if you want to actually take a look at the actual Java file, you can actually use -kip and hello impl. So let me just use this one. Yeah. RMIC -kip and hello impl. Okay, so now you can see the hello impl stub Java has been created, and also class also has been created. So if you want to take a look at this Java file that gets generated by the RMIC, you can take a look at that. Okay, so basically, it's pretty simple class. All right, so let's move on to the next step. So what we have done is created that stub class. Now we are going to write the, let's write the server code first. The server code, as we have seen in the slide, basically created a remote object. Again, when you create an object, it will call the constructor of its parent class, which is a unicast, which is unicast remote object. So it will be now exported. Okay, meaning it is ready to receive the call from the client. Okay, and so we compile the server class. Okay, and then the client code is pretty simple as well. So here is going to look up that hello, and then it's just called the hello method. Okay, so now we are ready to run the code. So we are going to so first of all, we have to start the RMI registry, right? Okay, so let's start the RMI registry. RMI registry. Okay, so RMI registry is up and running. Now we are going to start the server. So here we are going to say Java hello server, and then client is Java hello client. Pretty straightforward. So Java hello server. So now is ready for receiving the request from the client. Okay, and so hello server is now ready. So it registered itself the RMI registry, and now is ready to receive the call from the client. So we are going to create another terminal window, and here we are going to go, and now we are going to Java hello client. So yeah, now it actually calls the server, and it returns Sang Shin. So the name is hard coded. Okay, so hopefully that gives you a sense of how things work. I know there are a few questions, but let me actually finish the the dynamic class loading, because it's pretty important concept. So once I finish this presentation and hands-on lab, and then if I have time, I'll address the questions that you guys have asked. Okay, moving forward, dynamic class loading. So class bytecode gets downloaded during runtime. So as I said before, the class file is not part of the serialized copy, meaning the file, so the bytecode has to be downloaded during runtime. So when the caller does not have the class in the local class path, then it has to be downloaded. An example is like a stub class. In the example that we just have done, everything is a local space in the same directory. So the class files are all available in the local class path. But typically, you are going to have RMI server running on different machine, right? From the RMI client. In that case, RMI stub might not be in the class path of the RMI client. That's the time that class file, stub class file, has to be downloaded from the server. Okay, so that's basically what we are saying as dynamic class loading. So when the caller does not have the class bytecode in the local class path, it has to be downloaded from the server to caller's address space. An example is again stub class. So as we mentioned, the serialized copy of an object contains where to get the class bytecode information. So again, that is called code-based annotation. So when object gets serialized, where that class should be downloadable is supposed to be provided. Okay, so that's something that we are going to talk about. Okay, so who does provide this code-based annotation information? It is provided by the exporter of the class. Okay, by using export codebase property called java.rmi server.codebase. And this one is basically typically HTTP URL. Okay, so let me see if I have actually concept of import class path and export class path. Okay, so let me actually talk about this concept of codebase first, and I'll get back. Okay, so what is a codebase? I'm sure you have exposed to the concept of codebase, meaning import class path and export class path. It's the location where class bytecodes reside. Okay, there are two types of codebase. One is import codebase, and this is something that we are very familiar with. Okay, so basically this is the class path that is specified by class path environment variable or -cp or minus class path option when you're running Java application. So import codebase is the codebase your local VM uses to load classes it needs. Okay, Now, there is another concept of Codebase called the export Codebase, and this is sometimes called the RMI Codebase. This is something that you have not exposed unless you have worked with the RMI. It is a Codebase remote VMs use to obtain the class files exported from your local VM. Okay, and this is again specified by RMI server Codebase. So when an object gets serialized, this export Codebase information will be annotated with that serialized object by the exporter of the class. So that's the reason when the client receives that object, it knows where to get that code, meaning where to get the class file, because it has that information about this export Codebase. All right, so any object marshaled by the server will be annotated by RMI Codebase, meaning export Codebase. So when a client, so again, for remote object, the stub object gets marshaled and annotated with this RMI Codebase. So when a client instantiates an object, the bytecode of the class, meaning the class file, will be downloaded by the RMI ClassLoader from the location specified as RMI Codebase. Again, this RMI Codebase is inside that serialized object. Okay. All right, so the RMI Codebase could be in many forms. Of course, it could be HTTP, it could be FTP, or it could be file. And the class could be just like import class path. It could be jar, or it could be directory path. Okay. All right, so I'm going to actually go back to the presentation slide that I haven't talked about. All right, so when does this Codebase annotation occurs? So whenever objects get serialized, okay, this Codebase annotation, meaning RMI Codebase information, will be included in the serialized object. For remote object, the Codebase information of the stub class will be annotated, while for non-remote object, Codebase information about normal class. Okay, that makes sense, I hope. Okay, so when both client and server has the RMI remote interface in the local class, so this is actually example, deployment scenario, and let's see how things work. So both client and server has interface class in their local class path, which is typically the case, because client has to have an interface, right? Okay. However, the stub class is typically on the server, okay, meaning it's not in the client space. So client does not have hello world stub class in its local class path. But, it could have it, but, if it does, then it diminishes the whole purpose of class downloading, because, remote object could be recreated, right? So in that case, you have to actually pass the stub class file in the client, and that's not really, dynamic, okay? So you typically want to have this stub class on the server side so that it can be dynamically downloaded to the client side. And then server will export the hello world stub class via HTTP server so that client can get this class file during runtime. All right, so this is a continuation of this scenario. So client will get hello world stub serialized object from the registry. However, client does not have the class file of this in its local class path. So it will read this RMI Codebase annotation from the serialized stub object and will try to download it, this hello world stub class, from the location specified in the Codebase annotation. Okay, all right. So the code movement. So I think we talked about this one a bit. Performed in two phases. The serialized object or marshal object gets moved, and then class files gets downloaded. Okay. So in this case, the code movement, code is represented by the class files, and data is represented by the state captured in the serialized object. Okay. So the key point is that serialized object does not contain the class file itself. It contains the name of the class and RMI Codebase information of that class. Okay, so hopefully that is clear to you. All right, so serialized object, this is a bit of repeat, contains, my apology, values of the field of the object, and the name of the class, and again, location of the class. So this is the RMI codebase or export codebase I was talking about, via codebase annotation performed by exporter of the class. Okay. All right, so let's talk. Yeah, we actually talk about the concept of codebase, right? Okay. All right, so here, RMI codebase, as I said before, it is the exporter who provides this RMI codebase, okay? And any serialized object will contain information about this RMI codebase. So RMI server export classes that are needed by the client, for example, stub interfaces or other interface classes of remote object, okay? And again, if the client has these classes in the local path, no downloading occurs. And any classes that are needed by the interface and stub class will be also could be coming from the server. Okay. And RMI client sometimes will function the role of RMI server as well. So RMI client, initially it will get the remote object, and then remote object will call a method of the object that coming from the RMI client, right? In that case, RMI client is now plays the role of RMI server as well. So RMI clients sometimes have to export classes as well, because the classes are also needed by the server in that case. Okay, so this is how you can specify the RMI code base. So it could be just like an import class path that you know of. It could be directories. So you can say -d and Java RMI server code base. This is a file, and this is HTTP. Okay, and you can also specify the jar file. Okay, this is a file-based jar file, and this is HTTP-based jar file. And of course, you can have a multiple locations, just like you can specify multiple locations of jar file and directory in your import class path. All right, so let's do the second demo. I'm hoping I have enough time to do this. I have only 14 minutes. So I'm going to actually use the documentation, and again, you can certainly try these things out. It provides a very step-by-step anyway. So in this case, even though we are using a single machine, we are going to have different directories, okay? So that, it doesn't actually pick up the stuff class file automatically, okay? So we are going to have 3 different directories. One is interface directory. So here we are going to define interface, okay? And then we define the same code. Here, hello interface, but this time we also pass address object, okay? Which is serializable object. So question for you, is this remote object or non-remote object? Anybody? No audio? Interesting. Can you guys hear me okay? Roland, can you hear me okay? You sent me, okay, good. So you guys can hear. Okay. Yeah, I was actually asking you to send me the message. All right, so this address is a non-remote object, right? Because it's not the type of remote interface. Okay, so in this case, whenever we are passing address object, the serialized copy of this address object, not the stub of address, will be passed around. Okay, so we now create the address object, okay, address class, and then we are compiling these interfaces and the address object. So we create the hello world job, hello.jar file, okay. So it basically contains address class and hello interface class. Okay. Now we are going to create the server classes. Now we are creating server class in a different directory. Okay. So now it's home/server1. Okay. And hello input class is again contains say hello method. Nothing, and again it's actually receiving hello object. Nothing that much different from what we have seen in the first example. Okay. And then we are writing startup code. So here we are again, so this is another way that you can export object. So you can call, so in this case, hello info. If you see the hello info, we have not extended, in this case, unicast remote object, right? So you have to manually export that object. Okay, so that's perfectly fine scheme. So here you created your remote object. Okay, but it's not exported yet, so you are going to export it by using export object method, and you pass the remote object, and then you are going to register your hello2 object, okay, to the local registry, okay, and then we are going to create a classes directory, right? This is the directory that we are going to pass it as RMI Codebase, okay? And then we copy this hello.jar file in this class, okay? And then we compile them, okay? Because you need interface to compile this server code, okay? And then we are creating client class in client directory, okay? So we now have three different directories: interface directory, server directory, and client directory. And also server classes are being, is actually in public hello classes directory, okay? And this is the client code. Client code is not that much different from the what we have seen in the first example. Actually, code as far as the coding is concerned is not that much different. It is how you are going to export, okay? So basically, we do use the hello.jar file to compile it, okay? And yeah, we haven't talked about the security policy here in the first exercise because everything is actually in the local class path. But here, because things are coming from, let's say in this case, simulated server, you have to actually provide the permission, okay? And here we are studying RMI registry. If you have not studied it before, we have it here already. And then this is important. You are studying the server. Now, this is the code base I'm talking about. So here, what you're saying is that the file that could be the class files are residing in this file, okay? And the server is a local host, and then we also specify the security policy, okay? Again, this code base could be HTTP because I'm not starting HTTP, I'm just using file, but typically you want to start the HTTP server, and if you posted this hello.jar file on that HTTP server, then you probably want to use HTTP, okay? For the sake of simplicity of this exercise, I'm actually using file URI notation, okay? So in this case, the server is started, and then I am I'm actually starting the client. So here you are studying the client, and you also actually use the same code base just in case there are classes that are coming from the client to the server, okay? And here the result is going to be like this, okay? Let me see if I have this code. Let's see. Let me see. I have this code already. Oh, looks like I have it. So I'm gonna just run it. Okay. So I have run this code like probably 6 months ago. So I'm gonna just run it. See, things are working. So I'm going to go to home server src. And I'm going to just copy this guy. All right, server 2 is ready, and then I'm going to start the client. So here, let me see. I'm going to just have another command line tool. Here I'm going to go home client 1 src, and then I'm going to run this guy. Okay, so it worked. Okay, all right. So there is another exercise 3, which is also the providing another exercise of using Codebase, but I'm not going to actually work on that at the moment. So let me just finish.